Hello everyone, I'm teacher Guohao Huang. Today, I will introduce you the Unit 10, which is One-Way Analysis of Variance, ANOVA. As we have discussed previously, when we have two independent samples and want to compare their means, we can use an independent samples t-test. But what if we have more than two groups, like 3 or 4? In such cases, we can use one-way ANOVA. For example, if we want to compare the effects of 3 different learning modes on ARCS learning motivation, one-way ANOVA is an appropriate analysis method. In this case, we are interested in analyzing the differences among 3 different learning modes: racing game, competitive game, and no game. This is our experimental procedure. We have 3 groups. The first group uses a racing game system. The second group uses a competitive game system, and the third group uses a non-game system. After introducing the systems, participants undergo 7 weeks of practice with 1 hour per week. The first group utilizes a racing game-based practice system. The second group utilizes a competitive game-based practice system, and the third group utilizes a traditional practice system without any games. Then, in the 9th week, we measure their ARCS learning motivation. Now, let's see how to perform ANOVA. First, we open SPSS to read our Excel file. After importing it into SPSS, we click on Analyze and choose Compare Means. Previously, we talked about independent samples t-test. This time, we're discussing one-way analysis of variance, ANOVA. So we click on the ANOVA option. After entering, there will be a factor here, which is the groups we want to analyze. We can select the groups here, and then for the dependent variable we want to analyze, the average and total average of ARCS. Due to 3 groups, if there are significant differences, we will proceed to pairwise comparisons to determine. This is called post hoc comparisons. We need to set up post hoc comparisons, and there are many methods available. The most commonly used are these 3. The first one is LSD method, which is more likely to show significance, so we usually select this one. The second one is Sheffe method, which can be used when there are considerable differences in sample sizes. The third one is Tukey method, which can be used when sample sizes are equal. We can check these 3 if needed. Next, let's proceed to set up the options. In the options, there are 2 checkboxes to tick. The first one is for descriptive statistics, and the second one is for homogeneity of variance test. We need to fulfill the homogeneity of variance test requirement for ANOVA. Then, we click on Continue. First, we need to confirm the results of the homogeneity of variance test. For RTS and total average, their significance levels are both greater than 0.1, indicating they are not significant. This means their variances meet the homogeneity of variance requirement, and we can proceed with the analysis. If there were significance here, we would have to use another method instead of ANOVA. Since the variances for both ARCS and total average were not significant, we can proceed with ANOVA. Next, let's look at the results of ANOVA. We focus on the significance values on the right. We will notice that for the first 2 variables, A and R, their significance values are greater than 0.05, meaning they are not significant. However, the bottom 3 variables, C, S, and total average, have achieved significance. If it is not significant, we can organize a table like this. A and R are not significant. We can compile their groups, the number of participants, means, standard deviations, and F values. The F values are 1.057 and 1.443, so we copy them over. Then, for the means and standard deviations, we can find them in the descriptive statistics section and copy them over. This way, we have completed a table for non-significant results. It's essential to note that F should be in uppercase and italicized. Next, let's look at the significant part, which includes C, S, and the total average. Since these three are significant, we need to determine which pairs have significant differences. Then, let's examine the post hoc comparison using the Sheffi method. Regarding the comparison of means in variable C, the comparison between group 1 and 2 yields a value less than 0.05, indicating significance. However, the comparison between groups 1 and 3 is not significant. Since there is significance between groups 1 and 2, there is also significance between groups 2 and 1. There is no significance between groups 2 and 3, nor between groups 3 and 1, or between groups 3 and 2. In summary, only the comparison between groups 1 and 2 is significant. Therefore, following this pattern, we can organize a table for significant results. Typically, we start with the variables, followed by the three groups for each variable. Then, we include the number of participants, means, and standard deviations. Additionally, we include the F values. Since there is significance, there will be an additional column for post hoc comparison tests. Since we used the Sheffi method for post hoc comparisons, we will denote it in parentheses. We then indicate which groups have significant differences, focusing on the means. For example, for the mean of raising game is greater than competitive game. Now, let's examine the significance level. With a value of 0.02, which is less than 0.01, it corresponds to 2 stars. Similarly, for variable S, it only has 1 star. The same applies to ArcS, which also has only 1 star. That's today's introduction. If you have any questions, please discuss them with me. Bye-bye.